Dual RTX Pro 6000 on PCIe X8, myths, bottlenecks, and real-world performance. Running dual RTX Pro 6000 GPUs on a PCIe Gen 5 X8 connection, rather than the theoretically optimal X16, is a hotly debated trade-off among workstation builders focused on AI workloads. Reddit's technical consensus is clear. For most local large language model M inference tasks, PCIe X8 Gen 5 provides bandwidth effectively equivalent to Gen 4 or X16 and poses no meaningful throughput bottleneck. PCIe limitations mainly surface as longer model load times rather than slower inference, even when running advanced tensor parallelism. User anecdotes reveal that PCIe Gen 4 X4 slots only degrade inference by about 10 to 15%, and at Gen 5 X8 the drop is negligible, provided all model weights fit in GPU memory. However, bandwidth becomes a real obstacle in high-intensity multi-GPU training. Tasks like all-reduce operations in data parallel training or model and data swapping hammer the PCIe bus, so limited lanes directly throttle performance. Data center GPUs offer NVLink for direct peer-to-peer transfers, circumventing PCIe, but the RTX 6000 Ada and Pro Blackwell cards lack this feature, forcing all inter-GPU comms onto PCIe and making raw bandwidth even more vital for training and fine-tuning. Given the steep costs of CPUs and platforms with abundant PCIe lanes, like AMD Threadripper or server-class Xeon EPYC, many recommend used enterprise hardware. You can get an EPYC Xeon Plus motherboard for the same or less than a consumer Ryzen 9950 X3D, notes one commenter, citing plentiful second-hand servers with excellent lane support, albeit typically Gen 4, not Gen 5. Superfine distinctions between Threadripper and Xeon often matter less in practice than the total available RAM. Since dual RTX 6000s can present a combined 192 GB of VRAM, optimal system RAM recommendations trend sharply higher, 384 to 512 GB to match throughput, with 256 GB a bare minimum. Real-world performance hinges just as much on these memory ratios as on CPU or PCIe specs. Power reliability is another must. Workstations worth 5 figures need a proper uninterruptible power supply UPS to avoid catastrophic data loss or hardware risk. Ultimately, for local LLM inference, the headline hardware constraint is usually VRAM, not PCIe lanes. For fine-tuning or full model training, PCIe lane count and system memory can become limiting, at which point many opt to rent data center class GPUs, SXM H100s, in the cloud for better value per dollar. The meta message: don't let PCIe X8 Gen 5 anxiety distract from the real world, where inference runs just fine and budget should be funneled to RAM and stability unless your focus is heavy, parallel training. Secure LLM-generated code gets its benchmark. Amid explosive adoption of LLMs for coding, the security of AI-generated software has become an urgent topic. Traditional benchmarks, such as human eval or security eval, mostly evaluate standalone code snippets. This approach ignores the tangled web of interdependencies, build configurations, and deployment pipelines that real-world software presents, where vulnerabilities can lurk across file boundaries or emerge due to context leakage. The ASE, AI Code Generation Security Evaluation, benchmark from recent Arxiv research fills this gap with a repository-level, CVE-grounded approach. ASE curates tasks from actual open-source projects containing documented security flaws, packaging full repositories, build systems and all, and running automated containerized evaluations with expert-tuned static analyzers. The pipeline tests whether LLM-generated fixes not only resolve the target vulnerability, but also preserve buildability and functional integration, and advance over LLM as judge scoring or brute force static analysis. Importantly, ASE tracks how the amount and quality of context provided to the LLM, e.g. through retrieval-augmented prompting, impact both code robustness and security outcomes. Benchmarks found that open-source models, notably Qwen 3 235B A22B Instruct, can rival and sometimes surpass top proprietary offerings, like Claude 3.7 Sonnet, on the security metric, though overall quality is still led narrowly by closed models. Perhaps most strikingly, more intricate, slow-thinking prompting, chain-of-thought, explicit reflection underperformed fast, direct decoding approaches for secure patching, challenging popular assumptions around stepwise LLM reasoning. The research calls for future benchmarks to respect full repository context, automate build and test flows, and focus not only on functional correctness, but also on true security. T-function calling, LLM's hidden weakness. A new class of function calling LLM benchmarks is surfacing a deeper gap in the AI for coding world. While many models ace textual code synthesis, their abilities to generate complex, structured program representations like abstract syntax trees, ASTs, through function calling are much less predictable. The team behind AutoBE, an open-source backend generator, found that models with fewer parameters, like Qwen3 Next ADB A3B, handily outperform much larger siblings, e.g. Qwen3 Coder 450B, at AST generation for data transfer objects, directly contradicting what leaderboards on typical code benchmarks would suggest. AutoBE's pipeline treats AI models as AST builders, where their output is not mere free-form code, but structured, validated schema objects representing full back-end logics. Benchmarks show that models' real-world function calling skill diverges sharply from their headline performance scores, especially on complex, tree-structured data. OpenAI's GPT 4.1 family was found superior at building back-end applications for AutoBE compared to GPT-5, and several Qwen3 variants showed substantial variance in success rates for AST types versus text output. This suggests that, for advanced code automation or synthesis tools requiring deep function calling fidelity, choice of LLM should be guided by specialized stress tests, not just traditional programming benchmarks. The team is actively soliciting more candidate models for future benchmarking reports to shed light on this misunderstood capability gap. LLM Colosseum, Battle of the Bots. Evaluating LLMs at scale is notoriously difficult. Human voting via platforms like LLM Arena is bottlenecked and can be biased or inconsistent, while standard benchmarks rarely capture models' ability to interact or debate in dynamic adversarial contexts. Enter the LLM Colosseum project, a novel, open-source platform where models compete against each other in a kingdom-style competitive ladder. Here, LLMs act as both contestants and judges. Winners are promoted, losers demoted, and debates unfold multi-turn with problems sourced from challenging benchmarks and community submissions. There's even potential for models to generate their own adversarial tasks. However, user feedback highlights an Achilles heel. Since LLMs judge each other, hallucinated answers can still be ranked above one another even when both are wrong, subtly exposing the limits of current self-assessment approaches. Suggestions include integrating rating systems like Glyco2 or Microsoft's TrueSkill for more robust rankings, and enabling human overrides when models clearly fail. While rough around the edges, the Colosseum's 24/7 battles and emergent bot ecosystems make it a glimpse of next-generation evaluation tactics, potentially more scalable and stress-testing than static leaderboards. Model context protocols, Git repo context, and multi-agent advances. As local and cloud-based LLM platforms mature, the Model Context Protocol (MCP) is rapidly evolving, central to how LLMs orchestrate tool use, stream outputs, and interact in composable chains. Anticipation is building for native, streamable HTTP MCP implementations which promise Claude artifacts-style outputs and drastically easier integration of external tool servers. Devs complain that the current workaround is clunky to deploy. Once native MCP becomes mainstream, many expect a flurry of custom agent chains and smoother context sharing between models and tool endpoints, helping LLM-powered agents scale to new types of workflows. Meanwhile, practical issues like giving LLMs file context remain live. Tools such as llama.cpp don't natively attach whole Git repositories as context, so solutions focus on wrapping with libraries like llama cpp python, langchain, or llama index, which can embed, index, and dynamically inject context slices from an entire repo. Experimental utilities like OneFileM serve this exact purpose, reflecting broader momentum to bridge local codebases and LLMs in a modular, retrievable way. Lastly, the LLM Agents Ecosystem Handbook brings order to this proliferation, providing comparative matrices and practical guides to 60-plus agent frameworks, from DAG-based multi-agent systems to low-code builders and retrieval-focused orchestrators. Its coverage, from deployment and RAG to inference and benchmarking, now serves as a go-to resource for engineers assembling multi-agent pipelines, especially as new MCP features unlock richer forms of agent collaboration. New models and toolchains, Qwen 3 Max, ERNIE, Clauder, and beyond. Model releases keep coming at breakneck speed, led by Alibaba's Qwen 3 Max series. Qwen 3 Max Instruct tops most public coding and agent benchmarks, reportedly even surpassing GPT-5 chat on standardized leaderboards. Yet the model is only available via API, not open-sourced, a pattern in the Qwen line where the biggest, best models remain closed, while smaller high-performance but less compute-intensive siblings are given permissive licenses. Community response is pragmatic. Most users can't run trillion-parameter models locally anyway, so deep gratitude persists for the many Qwen variants that are open. The Max Thinking variant, still under final training, even claims 100% scores on some of the hardest math reasoning benchmarks, AIME 25, HMMT, especially when tool use and test time compute are turned up. Skepticism remains. Skeptics call out benchmaxing, the practice of optimizing models for benchmarks rather than real-world generalization. It's also widely acknowledged that Anthropic's proprietary agentic benchmark, used to rate Claude, may reflect more practical user demands than standard leaderboards. Elsewhere, Baidu's ERNIE 4.521b A3b thinking model posts strong results in complex reasoning, thinking length, context window up to 131,000 tokens, and efficient tool calling. Its Mo mixture of experts architecture activates only 3B of its 21B parameters per token, balancing compute cost and flexible deployment. Like Qwen, ERNIE is Apache 2.0 licensed and pre-optimized for both transformers and VLLM runtimes. Anthropic's Claude, meanwhile, gets expanding enterprise toolchains like Clauder, a now open-source toolkit providing zero setup access to 65-plus MCP servers, automated Git versioning, security guardrails, agent configuration, and project-level tool management, all with simple CLI integration. NVIDIA's Canary 1B2 deserves attention on a very different axis. It's a speech model, not text, and delivers SOTA automatic speech recognition and speech translation for 25 European languages with a 978M parameter fast conformer transformer hybrid. With CC 4.0 licensing and robust benchmarks, including state-of-the-art WRMET BLUE scores, up to 10x faster inference than some competitors, and efficient, robust translation, Canary is deployable for everything from voice bots to subtitle generation. Other notable releases. Inference for Qwen 3 0.6b has been written in pure C CUDA, useful for those seeking maximal speed and minimal dependency. Small 2 Operator, from the Small Agents team, establishes an open-source, reproducible pipeline for training small VLMs to localize and interact with GUIs by converting screenshots and low-level command traces into an agentic GUI coder, potentially foundational for future interface automation agents. Multimodal frontiers, video, Foley, and audio synthesis. The AI multimodal revolution continues apace. Tencent's Hunyuan World Voyager introduces a pipeline capable of generating world-consistent 3D point cloud sequences, effectively explorable 3D scenes, from a single image guided by a custom camera path. This enables rich scene reconstructions and immersive world exploration, as well as direct depth and RGB video to 3D object pipelines. Meanwhile, Comfy UI Hunyuan Video Foley brings realistic, text prompt-driven SFX audio generation for videos. Its flexible custom node system allows video segments to be transformed into synchronized soundscapes up to 15 seconds, with aggressive FP8 quantization to fit large models on modest GPUs, seed control for repeatability, and thoughtful memory management for VRAM-constrained systems. The toolkit's design features, like batched frame processing, compile time optimization for target hardware, and easy chaining for multipass workflows, are clever, making professional-level audio augmentation more accessible. Audio progress also shows in long-form TTS. FireRed TTS2 can now reliably generate 3-minute multi-speaker conversations with accurate speaker switching, low error rates, and support for over half a dozen languages, plus zero-shot voice cloning for code switching and dialogue. Its dual transformer setup, interleaving text and speech conditioning, enables natural prosody and fast response, while a friendly web UI brings advanced synthesis to non-specialists. New AI interfaces are closing the experience gap with ChatGPT. MajorLab offers an Llama-compatible, no-vendor locking, privacy-focused local solution with full speech integration, while MPC Studio aims for super-user privacy and local chat. And for macOS users, applications like Inferencer put token-level inspection, advanced prompt seeding, and on-device privacy front and center. No cloud processing, markdown and math rendering, and granular parental controls. Hacking and AI tooling Roundup. In security and automation, a new tutorial demonstrates how to bypass Cloudflare's robust turnstile CAPTCHA using Thermoptic, a proxy stack that leverages the raw Chrome debugging protocol, eschewing detectable JavaScript injection in favor of direct, mouse-fuzzed interaction. The method subverts Cloudflare's traditional bot checks, though the author is quick to note that anti-bot versus anti-bypass is always a cat-and-mouse game, and ethical use remains essential. On the DevOps front, tools like Panada help harden your GitHub Actions workflows by automatically pinning dependencies to specific SHA hashes, reducing attack surfaces from auto-updating third-party code. Lastly, a bit of robotics fun. A teensy 4.0 powered robot can keep a heavy metal ball balanced at the center of a flat touchscreen using stepper motors and real-time PID control, as reliable a metaphor for the work-life hardware balancing act of modern engineering as any.